This is problem number 1 for assessment number 3. In this problem it says find a formula for each function graph below. And they give you two piecewise functions to go ahead and write a formula for. So we can tell they're piecewise because we have these jumps here, and then you can see that they have the sharp edges, or in this case we don't have any edges at all. So we have different pieces to the function. What we want to do is we want to count the number of pieces. So we've got 1, 2, 3 pieces, and that's how we know how many essentially individual formulas we have to create. So we're going to say f of x equals, we're going to go ahead and make the brackets, and then we're going to leave space for the 3 functions. The first thing I like to do when I do a problem like this is I find the domains. So the domain of the first piece goes from -1 to 0, but does not include 0. It does include -1. So I say -1 less than or equal to x less than 0. For the second piece, it goes from 0 to 3, and 0 is not included, 3 is included. So we're going to say that 0 is less than x, which is less than or equal to 3. And then finally we're going to say from the last piece goes from 3 to 7, and it's included in the 3. So this, well, because I included the 3 in the middle piece of the function, or the middle function, I'm not going to include it in the end. So actually I'm going to assume that this is like an open dot, and this is an open dot going from 3 to 7. So we're going to say 3 less than x less than 7. So now I have the domains. Now you'll notice that 0 is not defined for this function. So if you were to be asked what's the domain of the function, you could not just say -1 to 7 because 0 is missing. It's kind of like a hole in the function because it's not defined in either spot. Let's go ahead and write the function piece for the first one. Well, I can see that its slope is negative, and it goes down 3 over 1, so its slope is -3x. The y-intercept is 0, so -3x is the formula for that. This is just a flat line at 4, so I'm just going to write 4 for the middle one. Y equals 4, of course, but I already have f of x equals here. And then the last one is a negative slope, and it goes down 4 over 4. So down 4 over 4, 1, 2, 3, 4. So that's negative, you could say -1x, and the y-intercept then, well, if we're going down 4 over 4, then we're going up 4 over 4, or in our case, we could go up 3 and over 3 and land on the y-axis, right, because 3 over 3 is also 1. So up 3 over 3 would put us at, well, if we're at the 4 spot right now, up 3 puts us at 7. So we're at the y-intercept of 7, so plus 7. Now for the second one, we do the exact same thing. We write the 3 pieces, or 3 chunks here, and we find the domains of each. So for the first one, its domain goes from -3 to 0, and it includes both. So -3 less than or equal to x less than or equal to 0. The second one, it goes from 0 to 1, but does not include 0, but includes 1. And the last one goes from 1 to 5, but does not include the 1. So we're going to go 1 less than x less than or equal to 5. Now I'm going to write the formula for this line right here. That would be going up 1 over 1, 2, 3. So up 1 over 3. So this is 1/3 x, and then plus 0 for b. So I just have 1/3 x. This is a negative slope, so it's down 1, 2, 3 over 1. So the slope is -3. And x, and then our y-intercept is plus 3. And the last one's a flat line at -2, so we're just going to say -2 for that function. And that's how you write the formulas for the piecewise functions.